Okay, first we'll see what is a structure and how to use these structures in programming this. Hello?
Hello?
Yes. Is it visible?
Yes, sir.
Yes. So see here, first, what is a structure? So what is an array? So we have come across with arrays, right? So we have seen arrays. So what is an array is? Array is a collection of elements which are homogeneous. That means it is a collection of elements which belong to one data type, one category. Whereas in the structure is a collection of related elements, possibly of different data types. So where those different data types were given one name. Suppose if you are collecting integer elements of 20 integers, so we'll call it as an array. Suppose if I have a collection of elements where all the elements in that group belongs to different data types, that collection is called as structure. Okay. The structure is a collection of related elements, possibly of different data types. Different types means different data types. So where all the that collection so will be given one name, and that collection is called as structures. Okay, each element in a structure is called as a field. Each element in a structure is called as field. Look here I have a structure. So where I want to store, there is a group of data. So where in that group of data I want to collect the ID, that means the roll number, the name, and grade point, GPA, that means grade point average. Okay. So when you have this type of collection, we call that collection as a structure, and you can give one common name to this complete structure. You can give one name to this structure. So let us say I'll give the name of this structure as student. Name of this structure as student. Student is the name of this structure. So where in this structure, suppose if I want to store the roll number, so it is integer data. Suppose if I want to store the name, this is one character array. Suppose if I want to store grade point, it belongs to a data type float. So where in this collection of student structure, I have different fields where each field is belonging to a different data types. Whereas when you call an array, you'll have 20 elements or 50 elements where all the 50 elements in that array belongs to either integer or float or character, one type of data. Whereas in the structure, you'll have the collection of elements. So where that collection of elements belong to different data types, and for that different data types, you can give one common name. Here the common name I have given in this example is the name as a student. That means here I am storing the details of a student. So where you'll have an integer identity number, a character array name, a float which is grade, point, average. So here all these fields, all these ID, name, GPA, they are called as fields in the structure. Okay, you can have a structure which belongs to, each field may belong to a different data type. That is what we call as a structure. So now we'll see how to declare this, define the structure in a C program. So this can be defined like this. So like all other data types, the structures must be declared and they have to be defined. See how they are defined. So they are defined with this keyword called as struct. We use a keyword called struct. Struct is a keyword used, and you can give the tag as any name which you wish to give for the structure. Tag indicates the name which I can give to that structure, and opening and closing flower braces ends up with a semicolon here. So in between these 2 points, you can give all the fields. So what fields I want to keep inside that student structure or whatever structure, you can place all of them, all those fields in between these 2 points, which is the opening flower brace and closing flower brace. Okay, so on the right side you can see the example. Say I'm writing struct. Struct is a keyword, and name of my structure is student. Name of my structure is student, and inside this student I have different members. My members are like this. I have a character array ID, I have a character array name, and I have integer grade point. See, I have 3 fields here where all the 3 fields belong to different types. So 2 of them belong to character data and 1 belong to integer data. So where all these fields were given a name called as student. Student is a tag given to that structure. So to define any structure, you have to use this keyword called as struct. We have to use the keyword called struct. So is it clear?
Yes, sir.
See, after declaring the structure, now we have to declare the structure variables. So this is another way of defining the structure. And coming to the structure variables. So once if you declare the structure, then you have to declare the structure variable. Just defining the structure is this part. Defining the structure indicates you are just telling to the compiler that this is the name of my structure and these are the fields I want to include in that structure. That's it. And later you have to declare the structure variable. So structure variable declaration is this one, which I'm drawing in this black color. Struct student, and this is the name of the structure variable. A student is the name of my structure variable. Like we have a variables like int x, right? So x is a variable which belongs to integer data. In the same way, a student is a structure variable which belong to struct student type. Here x is nothing but this variable name, a student. Int is nothing but the type, which is struct student. So whatever is the name of the structure I define, I can declare the variable with that name. So I already defined a structure with a student. So for that structure, I can declare a variable, which is struct student a student. Okay. On the right hand side, this is the another way of declaring. So you don't look at this because it is a bit confusing. Okay, so this is how you can declare the structure and declare the structure variable. There we have discussed now 2 points. So one is how to declare the structure. So structure declaration is this one. I'm just defining the structure. What is the name of my structure is student. What are the members? What are the fields I want to include? You can call them as fields or you can call them as members. Structure members or structure fields. So what are the members of the student structure? ID, name, and grade point. You can write any members as per your requirement. You can write only 3 members, you can write 10 members, any members you can write according to the requirement. So here I am defining a structure with these 3 members, ID, name, and grade point. If you wish, you can define a structure with a different way. Like you can write ID, name, his branch, his year, his college name, his grade point. Okay, I can define the structure according to my wish, my choice. And after declaring the structure, then you have to declare the structure variables. So structure variable declaration is this one. This is what a structure variable declaration looks. A student is a structure variable. So which is of type struct student. So here you have two parts you have. One is the members of the structure and the second one is a structure variable. Member of a structure is something which you write inside the structure. Structure variable is one which you can hold some values. Which it can hold some values. See, you have to relate these two. You have to relate the structure variable with structure member. See how the structure variables and structure members are related. See, I have a structure like this with X, Y, T, and U. These are the different members. X and Y are integers, T is float, and U is a character. So for that, if you want to include some values, you can write the values like this. This is what we call it as structure initialization. Structure initialization. SAM1 is one structure variable where it can hold all the values of these variables. It can hold the value of X, it can hold the value of Y, it can hold the value of T, it will also hold the value of U. So I am assigning a value 2, 5, 3.2. So these are the values I am initializing to this structure variable SAM1. SAM1 is a structure variable. For that structure variable, it can hold all the values of X, Y, T, and U. So these are the values I am initializing for X, Y, T and U. This initialization is called as compile time initialization. This initialization is called as compile time initialization. You can also initialize your structure variables at runtime. Structure variables can also be initialized at runtime. So next we will see how to initialize the structure variables at runtime. See, to access the structures, you require one operator. That means to initialize the members of your structure at runtime, you need to access the members. So those members can be accessed with one operator. That operator is called as dot operator. So there in C, you have to use some hierarchical naming convention. That is, first you have to use a structure identifier, that is the name of the structure, and then the field identifier, which is the field. See, a student is my structure variable, ID is the field. So these two can be combined by using this dot operator. Okay, you have to follow this convention for accessing the structure members or structure fields. You cannot refer them directly. You cannot simply say ID, name, or grade point. To access the structure members, you have to follow this hierarchy. The hierarchy is, first you have to write down the name of the structure and then the field, which is the member of the structure. And these two have to be combined with this operator called dot operator. These two have to be combined with this dot operator. See, a student dot ID, a student dot name, a student dot grade point. Okay, I'll show you with an example. Include stdio.h. Void main. So first I'll define the structure. See, struct. So you have to use the keyword struct. I'll give some name. Okay, let's take the same example. Struct student. So in between these 2 points, you have to specify all the members what you want. I'll say roll number, name of 20. This is character array. Float is average. So these are the 3 members I want to store. Okay. So after defining the structure, now I'll declare the structure variable. See how I'll declare? I have to use the same struct student. Let us say S1 is one student. So this S1 is one student, where this student S1 will have all these details. What details S1 will have? S1 will have a value for ID. That is what? Roll number and some place for storing the name, and some place for storing his average marks. Okay, so now I'll ask the user to enter these details. Printf, enter the details of student 1. The user will enter the details. See how I'll read the values. Scanf, percentile D. The first percentile D is for storing the roll number. So whose roll number? Roll number of S1. So I have to write like S1 dot roll number. Next, I'll read the name. So for reading the name, I'll write percentile S. S1 dot name. And I'll read scanf percentile F. So this time I'm reading the float value. S1 dot average. Okay. Now I'll display the same values to you. Student 1 details are. So I'm displaying the same values of whatever are given by the user. The roll number is percentile D. So what I'll say? S1 dot roll number. Name percentile S. S1 dot name of that student. Average percentile F. S1 dot his average marks. So user will give me some values which I am storing those values and just displaying all those values on the screen. That's it. So it is asking to enter the details of student 1. So first I need to give the roll number. I'll say 101. Month. And I'm giving some average. 79. 79.45. Because I can give a float value here. See, his roll number, his name, and his average. Okay, I have not given slash in here, so I'm getting in the same line. That's it. So these are only the details of one student. Suppose if I have the other student S2. Other student S2. So this time also, so S2 is another student who will have all these values again. So first is roll number, name, average. So first roll number, name, average. So now you can identify the difference. Suppose if I say roll number, suppose if I say just the roll number, whose roll number it is, whether it is S1 student 1's roll number or student 2 roll number. So there is an ambiguity, right? So to avoid that ambiguity only we are writing like this. S1 dot name. So now it is clear This is the roll number of student 1. The same way, name. Whose name? S1 dot name. Name of student 1. Suppose if I want a name of a student 2, I'll write like this. S2 dot name, S2 dot roll number, S2 dot average. So you got it? Hello?
Hello.
You got it?
No, sir.
No. Fine. So what you didn't get?
What is the average F? Percentage F.
Percentage?
F.
Percentage F is for reading a float value. Because average is a float data type, we'll write percentile F. Percentile D is only for integer data. The same way, character array, I can write percentile S, which means a string. Okay?
Okay, sir.
Okay. See, I'll update the same program, I'll update. So let us take details of student 2 also. I'm taking the details of, enter the details of student 2. So it will simply take S2 dot roll number, S2 dot name, sorry, S2 dot average. The student 2 details are, so what is the details of student 2? S2 dot roll number, S2 dot name, S2 dot average. See now. So first it is asking to enter the details of student 1. I am giving the details of student 1 first. 78.90. So now it is asking, enter the details of student 2. I'll say 102 Raju 67.890. See, these are the details of student 1 and these are the details of student 2. You can declare any number of such structure variables. Any number of structure variables. You can even declare a structure variable of type array, where all of them belong to one data type, that is struct student. Okay. So is it clear up to this? Hello?
Hello.
Is it clear? Okay. So same like structures, we have another type called as unions. Same like structures, there is another type called as union. So where this union is also have the same definition like structure. Union is also the collection of dissimilar data items or different data types. But there is a major difference between the structure and union. Is so one major difference is when you are declaring a structure, we use a keyword called struct. When we are declaring a structure, we use a keyword called struct. When we are declaring a union, we use a keyword called union. And the remaining syntax is completely similar to structures. Only instead of a keyword struct, we replace that with the union. And there is a major difference between the structure and union is in terms of the memory. In terms of the memory. See, what is the difference between these two in the case of a structure is, see, suppose if I have a structure like this, what is the size of this structure variable is, suppose let us say I have one integer data. Let us say the size of integer is, let us not do it as 4 bytes. The size of an integer is 4 bytes. And to store the name, we have a size of 20 characters. So one character occupies 1 byte and 20 characters occupies 20 bytes. And we have another type which is a float, which occupies 8 bytes. So this is all the memory that is allocated for S1. Now what is the size of S1? It is 4 plus 20 plus 8. A total it is 32 bytes. That means, hello?
Hello.
Is you there?
Yes.
Yes. Suppose if I declare one structure variable, say S1, the size of this S1 is, each structure variable size is 32 bytes. So S1 size is 32 bytes and S2 size is another 32 bytes. So which can store again a roll number, name and average. That means size of each structure variable is sum of the sizes of its members. Sum of the sizes of its members. So I have 3 members and the sum of the sizes of those 3 members is the size of my structure variable. Say it as S1 or S2 or whatever name you give. The size of each structure variable is sum of the sizes of its members. Suppose if I have 10 fields in a structure, sum of the sizes of all the 10 fields is the size of that structure. Got it? Okay. And the other type we are discussing now is union. So what is this union is? I can write union like this. Union student. Suppose if I say int id, the char name of 20, float average. Suppose this is union. In the same way, you can have a structure also. Struct student int id, name of 20, float average. See, I already told you what is the size of a structure variable. So the size of this structure variable is 32 bytes. Now coming to the size of a union variable. Union variables are also declared same like the structures. I can use a keyword, say union student US1. So for differentiating structure, I'm writing U underscore S1. So U underscore S1 is one union variable. See, structure and union both means the same, but they are different in terms of the memory that is allocated to those variables. I can declare a structure variable like this. Struct student S1. S1 is a structure variable. S1 is a structure variable whose size is 32 bytes. Whereas union is also almost 99%, it is similar to the structure. Only difference we have is instead of the keyword union, sorry, instead of the keyword struct, I'm using the keyword union. That is the only difference. The remaining things are almost, it looks similar. But the major difference in between the structure and union is in terms of memory allocation. These two differs in terms of memory allocation. Other than the keyword we use, these two types, so they are different in terms of the memory that is allocated for them. Size of a structure variable, that is S1, is the sum of the sizes, that is 4 plus 20 plus 8. So which gives you 32 bytes. So this is the size of a structure variable. Whereas coming to the size of a union variable, they are different. It is having the maximum size of all its members. So it considers the sizes of all the members, and out of all the sizes, whatever is the maximum, that is the size of the structure variable, which is U underscore S1. So what is the maximum size of all the members here? Max of, so what are the sizes of their members? First member is 4 bytes, second member is 20 bytes, and the last member is 8 bytes. So what is the maximum of these members? So 20 is the maximum value. So size of my union variable is 20 bytes. Size of the union variable is 20 bytes. Size of a structure variable is sum of the members of its structures, sum of the sizes of its members, whereas size of a union variable is maximum of all the sizes of its members. Out of all the members, whatever is the maximum size it has, that is the size of a union variable. So you got the difference between these two? Hello?
Hello.
You got the difference between these two? Hello?
Hello.
Yes or no?
Yes, sir.
Okay, so with this, our course is completed. So still, if you have any doubts,